Hello, Neural Network listeners. This is your co-host Arman Priyadarshan, and in this episode, we'll be continuing our interview with Dr. Liu. Hope you enjoy. I think like all the applications of large language models you're mentioning are really interesting. And one question I had is like, how are you like formatting and collecting data for all these different and diverse applications? So I know like in the case of web like users that are malicious and trying to detect those, like how would you like format that data and present it to a language model and before using that to determine if they actually are malicious or not?
Yeah, this is the problem. When we have when we do that, we need the data. Okay, so no matter what kind of a large language model work or AI work we're working on, we need the data. So I mean, when we do that, we have two ways. One is manipulation. So we will do some manipulations in our lab. So we will have a small number of real samples from social media, let's say, for instance, or from e-commerce. And we will do some algorithm called data augmentations. So we will automatically use machine learning to generate the similar data to train the models. So for example, what kind of data can be safe data? What kind of data can be suspicious data? What kind of data can be very risky data? So we will educate a model by using data augmentation method. So that's one way. Or the other way is that we have a collaboration with industry partners, so they can provide us some data. But if the data is user level, so most of the time we cannot access those data on the campus. So we have to find a student and provide an internship. So students will go to the company and get account there and access their data when they do the internship. So this is also what we did for our early studies.
Mhm. And what would like the format of this data look like?
You mean format of what? Format of data?
Yeah.
Yeah, I mean, different kind of data can be different. So, for instance, share you with a example for young user protection for pornography content detection. So we collaborate with some e-commerce platform. So they provide us the data, pretty large data with billions of transactions. So we find what kind of transactions related to pornography content. So what kind of transactions can be safe. And also they provide a very large amount of user behavior data. So for example, how long users spend on a specific item and what's their behavior after that, maybe like a purchase or add to favorite or remove from the cart, something like that. So we will use that to train the models to detect what kind of a product can be safe or not safe for young customers.
Hmm. And do you guys actually train these models from scratch or do you fine tune like pre-existing ones?
Once again, different project can be different. So some project we need to design our own model. So we need to start from zero. Yeah, and we need to design all the infrastructure ourselves. But with the other projects, for example, like a recent work in large language models, so it's really hard to start everything from zero. So we will use some open source packages to support our foundations of the models. For example, like Llama from Facebook, from Meta. So we can use that to some of our study. Yeah, so it's depend on different project.
Yep, that makes sense. What recent advancements in NLP or deep learning excite you the most?
Uh, I would say natural language processing, this AI, this field is very fast. It's moving very, very fast. So I mean, from research viewpoint, the large language model is not totally new. It's already been there for a couple years. So I don't think we can call that new exciting stuff because it's already been there. So I think the reason I see in my class, for example, I talk about Sora. I see Sora is pretty exciting. It's like a combination of text mining and video mining, so to generate the videos. So Sora, I just give a lecture to my class about it because Sora is still a black box, but I talk about the diffusion algorithm, how Sora may work behind the application. But I want to see those Sora outcome is pretty exciting. Yeah, I would say Sora, something like Sora, like image generation or video generation, going to be uh, change our life a lot. So I give my students warning, like if you're interested in like movie industry, movie making industry, so you may want to pay a lot of attention to these kind of technologies because it may change your future. So some of the jobs may disappear or may shrink a lot. So yeah, you may want to pay very attention to those advancement. Yeah.
Actually, could you elaborate or could you talk a little bit more about like how the architecture behind Sora works? Because I think it's really interesting too, and I haven't like looked too far into it yet.
Me as well.
Yeah. So Sora is once again, Sora is still a black box. So we don't know exactly how Sora really works. But what we know is based on maybe diffusion model plus transformer. So this is all the information we got so far. So it is a diffusion model help to generate the pictures or the screenshot from a video. So one by one. And the interesting part is because it's the all those images eventually going to contribute to a video and tell a coherent story regarding the textual input. So I think they use the technology like a diffusion model plus transformer models together to generate a video and a pretty long video, more than 60 seconds to tell coherent story. So yeah, those can be pretty exciting.
And also, can you talk a little bit more about like some of the risks that come with this, especially for like society as a whole?
You mean the risks of Sora or risks of video generation? Is that what you mean?
Yeah, pretty much just like generative AI and as like a whole kind of, and Sora specifically.
Oh yeah, I mean a lot. I would say a lot. So one thing is for our students is like some of the jobs will disappear, I believe. So this can be a pretty pretty bad for some of students.
Yeah.
Yeah, so I tell my student that even though I don't want to say that, but if you're working on, for example, you're professional, you have really a passion, you have a strong passion in in video making, in those short video generations, in like for the Photoshop, and back a few years earlier. So this can be pretty hot area. So you can find a very good paid job by using those techniques. But after, Sora generative AI comes out, so then uh, you may want to pay attention. So because future your job may be replaced by AI totally.
Yeah.
So I would say this is can be risky for some of students, especially for your career decision making, or you choose which career you want to take in the future years. So this can be a big decision. Well, the other thing is we find that recently generative AI like Sora video generation have been used in different contexts. Some of the contexts really may not really good. So for instance, recently we find some elections, so they create the videos. So for example, for the people already died. So to support a certain campaign or to support a candidate, so which generate uh, some moral issue. So whether this should be acceptable or not acceptable. So in different countries, in different contexts, in different culture, the answer can be different. But overall, we still have a deep concern about that. So when we can use generative AI to generate some not true data, some fake data, so eventually, yeah, this can be a problem for free speech and for democracy.
Yeah. You talked about some of the job industries that be affected inside the future, such as the movie taking industry. Are there any other that come to mind that you think would be affected tremendously in the near future?
Yeah, and still, so for example, I'm a professor also in data science, so I think basic data analytics also it can be a problem because right now you can give some data. So earlier, I mean, for example, if you use a SPSS or if you know like Excel pretty well, so I think it's helpful. It's quite helpful. But those easy operations right now can be done by AI algorithm. So you can just using spoken language, so give some command and some data, and the model can do something for you. Easy operations, even create like a tables, some chart, and even the report for you automatically. Right now, the quality is not very good yet, but it's improving. GPT is improving. Large language model is improving. So
Yeah.
I would say in future years, so those one day work very well with Office applications, and then those data analytics work entry level may have a problem too.
Hmm. And I think like one thing I had a question about was with video generation AI and like image generation. Do you think that diffusion models are entirely the way forward? Do you think they're going to improve a lot? Because I know like especially with some image generation models, like I guess like DALL-E 2 and Stable Diffusion. I know like the quality of the images isn't too great sometimes. So like, do you know if like Sora is a lot better in terms of fidelity, or do you think it's going to improve, or what are your opinions on that?
There are different tasks. So once again, I'm not a professional guy in image generation, but to the best of my knowledge, so image generation is developing pretty fast. So if you use a GPT to generate images, so when you use DALL-E, you will find that some photo, for example, I recently asked GPT to generate some poster for my class, but the details when you zoom in to the poster overall it looks okay, but when you zoom in, you find a lot of errors, a lot of mistakes, even spelling mistakes within the poster. So which means the quality is not very good yet. But I would say it's improving. So when you use diffusion model, stable diffusion model is more like a family of models. So right now there's quite a lot of variations recently. So one example is one diffusion model work along with transformer models. It may improve the performance. I would say this is a pretty fast developed area. And once again, Sora is still a black box for us. So we just know the basic structure, but we don't know what they do behind the model. I would say there can be a lot of engineering work, but so far, when they see the quality of the models, is much better than traditional diffusion model or traditional stable diffusion model. So I think they may do something, on the training data, and they may do something. They may have their own training data specifically, and they may have something specific on the engineering end, but the performance looks much better than the traditional diffusion models.
Hmm. Okay. Moving on to the next topic. So your recent research focuses on AI explainability and trustworthiness. Could you elaborate on the challenges in this area and potential solutions?
Uh, yeah. So explainable AI is that we want the AI algorithm to work, but most of the AI right now are deep learning. So we just provide you a outcome. The outcome is pretty good, pretty accurate, but not entirely trustful. So for instance, the insurance company, for instance, if they reject people's insurance request, like because of your occupation, because of your income, that probably okay. But for efficiency and accuracy reason, if they reject specific guide regarding the race and gender, and that's not acceptable, right? So we want the model to be able to explain why it is making such decision. So this is very important. So this is how explainable AI really work. So when we work on the performance side, when we only target on the performance, so the model just provide a very, for example, deep learning model, very, very deep model with many, many parameters, but it's very hard to interpret why the model making such a decision. So we want to transparentize, we want to make the model a little bit easier to understand why the AI model making such decision. So which is very important, I believe, in certain domains. For example, for drug development. So if machine learning model believe certain drugs or component can be useful, so we want to ask the reason why you make such decision. Is that because certain component, because of a certain gene mutations, because of a certain organs, because of some very specific, more complex reasons? So the AI model should be able to provide those reasons for us. Yeah, that's explainable AI will make the model more trustful.
So how can researchers ensure that AI models are transparent and interpretable?
So we will provide, I mean, once again, there can be different approach. So one of the popular approach right now is to provide a teacher and student model. So the teacher model can be a deep learning model, very deep, very hard to understand. But the teacher model will teach a student model. So the student model will be a easier linear model or a understandable model. So let's say a linear model. So the linear model try to reproduce the deliverable from the deep learning models. And so then we will take a look how those linear models make decisions. So which will give us a way to understand how deep learning model really work. Okay, so we will use the easy model or understandable model to reproduce the deep learning model deliverables. And then we will be able to take a look at the linear model, the easy model, understand why the deep learning model is making such decision. This is just one example.
Yeah, absolutely. Your research involves graph-based methods for natural language processing. Could you elaborate on how graph structures enhance NLP tasks like text summarization or entity linking?
Sure. So a lot of information right now is not isolated. And it's not just isolated information. So, for example, if I ask a question like uh, who is the president of the United States? So the GPT model, what they do is next token generation. So by learning a lot of data, by learning a lot of data, so they be able to generate the names like Joe Biden, one word at a time. So by generating the word or the word embeddings, and we can sample and find the most trustful word from the dictionary. So this is what the GPT is doing. But sometimes when we working on a very when the training data is not entirely trustful or the training data is very sparse in specific domains, then the GPT way generation is not very good. As you said, may generate some hallucinations. And so one thing we can do is using knowledge graph. So knowledge graph interlink all the entities, all the concept by using the graph format. So for example, if we have an entity, United States, and we have another entity, Joe Biden. So these two entities link together. So like Joe Biden is the president of United States of America. And then we can use this graph to generate answers. So we call that KGQA, knowledge graph based question answering. So these both techniques can be have its advantages and the disadvantages. So right now we're trying to train the model to incorporate both. So we will generate a QA model to get an answer, generate an answer by using both graph data and the textual data. I may have question for one. I may have time for one more question, maybe.
Okay.
Yeah.
I guess if we're having one last question, what advice do you have for students interested in pursuing research in NLP or data science?
Yeah. So yeah, number one, appreciate the students who are interested in this area. This area is quite exciting. So if students you are interested in this area, so you can consider to participate in three different levels. So I would call that a black box, white box, and a gray box.
Mhm.
Black box means that you just know the algorithm, you just know the model is how to use it, why this is useful. So, but you can use the model like a black box. So, for example, like a large language model. So you can use a large language model for your task without understanding the details of the model, because the model, like transformer model, attention model, those are parameter metrics, the multi-head attention, those can be pretty challenging. So you don't have to understand the detail, but you just know why and how this model may work to address your problem. So that's a black box way. Well, another students, like a PhD student, so if you're interested in, or if you have a strong passion in this area, and you don't just want to use the model, but you want to enhance the model, you want to provide a new way to make the model works better, and then you may need to transparentize the model. You need to understand how the model really works in detail, and you need to understand the mathematics behind that. So I would say, student, if you're interested in this area, you want to work for those new big companies, like if you're interested in Google jobs, OpenAI jobs, Amazon jobs. So you may need to investigate the mathematical details. So you learn the model in a white box way. And of course, there's another way in the middle is the gray box. So you when you know the basic infrastructure of the models, but you don't know the mathematical detail, this can be still helpful. and then you can maybe tailor the model a little bit by changing those hyperparameters. So it is still helpful. So I would say student interested in, you may want to make a decision whether you want to learn a model as a black box or the white box or the gray box, so which can be helpful.
Absolutely. Thank you so much for sharing all the different ways that individuals can get involved
Sure.
inside. Very,
It's my pleasure. Thank you very much.
thank you very much for your time as well. Have a great rest.
Thank you. Thank you. Bye.